In this problem, we have 3 pens, 2 markers, and 1 highlighter. And the way this problem is going to work is that we're selecting one of those items at random and then do not return it to the box. So if we have this box right here and there's 3 pens, right, a pen and another pen, and then another one over here, 2 markers. Could have probably just wrote an M, but that's okay. Marker, marker, and then 1 highlighter. You reach in and you take one of these out from the bin. Let's say you grab the pen and you take it out. Well, then you don't return it. So how many are left in the box? On the second time you're going to reach into the box, there are only 1, 2, 3, 4, 5 items. And that's because you're not replacing what you take from the box. So we want to know, what is the probability that Tara selects 1 pen and then 1 marker? Alright, so there's 6 things we can choose at first, and then there's 5 things left over on the second pick. So this is the first pick from the box, and here is the second pick. So that means there are 6 times 5, or 30 possible outcomes. There are 30 things that can happen. And I guess we can see some of this if we draw a tree diagram, because on our first trial we could pick a pen, or a pen, or a pen, or a marker, another marker, or a highlighter. Now I'm not going to draw this entire diagram because I don't want to draw 30 branches, but we can see what's going to happen here by drawing out and expanding this first branch right here. So if we chose a pen on the first pick, on our second choice there are still 2 pens left over. There are 2 markers and a highlighter. So what does that mean? Well, if we chose a pen, right, that's 1 possibility. There are still 5 possibilities left after I pick that 1 pen. So there are 5 possibilities here. That means also for this pen, there's be another 5 possibilities. So I'm just going to write 5 there. And that would again be a pen, a marker, and a highlighter. And the same thing for this pen, right? Because if I chose a pen in the first try, there are still 2 more pens, 2 markers, and a highlighter left. So far we have 5, 10, 15 possibilities. For the marker, there will be another 5 possibilities. However, there won't be 2 markers available. What will be available for both of these markers will be 3 pens, because we haven't taken a pen. We're assuming we haven't. There's 1 marker left, because we already took 1 of them. And we still have the highlighter. So these are our 5 possibilities as well. So we have 5, 10, 15, 20, 25. And for the highlighter, there will be 5 possibilities. The 3 pens, the 2 markers, and no highlighter, right? Because we took that highlighter in that case. So these are all the possible things that can happen, and that's 30. And the reason we're multiplying is because we're saying for each item you could have chosen the first time, there are 5 different items left the second time. So that means you have 6 groups, 1, 2, 3, 4, 5, 6, of 5. And that's what multiplication is. 6 groups of 5 means 6 times 5. So probability, I mean, we can cross out these 2 because they're out of 36. Those would be the case if we never took, if we put the pen or pencil back, right? Because there would still be 6 items. But that's not the case here. We have 30 items, 30 outcomes. Anyway, we're looking for the probability that Tara selects 1 pen and then a marker. So we can see that by using the phrase "and then," we're implying that there is an exact order, right? If we choose a pen and then a marker, I think what they're trying to say here is that it has to happen in that order. And so the amount of ways that can happen is we have a pen here, and then 2 ways of getting a marker. So that's 2 possibilities right there. And for each of these cases right here, there will be 2 ways to get a marker after we choose a pen. We don't have to consider these choices down here because in both cases here, markers are chosen first, and here a highlighter is chosen first. We're looking for a pen followed by a marker. So pen, 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 and there are 2 markers, 2 ways to pick a marker from each selection of a pen. Okay. And so that means that there are 6 possible ways out of 30 to get a pen and then a marker. And that's 1, 2. There will be 2 here out of the 5, and then 2 here as well. That's 6 out of 30. So in this problem, you can say there are 6 out of 30 ways to solve this.